Okay, in this YouTube I'm just going to answer a couple of questions here from exercise 7D from this here exercise, and specifically some of these ones towards the end of the exercise, question 8, question 9. So and I'll do a couple. So I'll do question 8 firstly. I'll do question 8G. Now what we're asked to do here is we've got an equation here of a quadratic equation, y equals x squared plus 8x plus 7. And we're asked to complete the square, or sketch the graphs by completing the square, and label the turning points and the intercepts, righto? So what we're going to do is we're going to complete the square. We've been asked to do that, so let's go and do that. Now this is x squared plus 8x. I'm going to clear this plus 7 out the road, and I'm going to put in its place in here the square of half of this. Right, half of that's 4, square it 16. I'm going to subtract the 16. See, my red numbers cancel each other out, and the blue number is just held from the line above. Now these three terms form a perfect square, x plus 4, and 7 minus 16 is minus 9. Okay, so now I've written it in this turning point form, so I can tell already now that my turning point is going to be minus 4. Remember the opposite sign of that, minus 4 minus 9. I know that's going to be my turning point. But I need to know what my x and y intercepts are. Now my x-intercept is at y equal to 0. Y equal to 0. Alright, so I need to solve this for y equal to 0. Okay, now that's alright, that's doable. Now you might have gone up here and done it this way. You might have solved x squared plus 8x plus 7 equals 0, and from there gone x plus 7, x plus 1 is equal to 0, therefore my x-intercepts are minus 7 or minus 1. You could have done that. But what we're going to need to do in question 9, and what I'll do here, is solve it using this form here. So I'm going to solve the equation by taking this 9 over this side. So I'm not using the null factor, the 0 thing rule anymore. I'm going to use x plus 4. I'm going to take x plus 4 squared equal to 9. You see what I did there? This 9, minus 9, came over this side, became positive 9, but then I just switched them around because I like my x's on the left. So therefore, if I take the square root of both sides, now x plus 4 is equal to plus or minus 3. The square root of 9 is 3. Okay, now solving for x, remember, so now I've got positive 3, I've got to subtract 4 over this side, haven't I? This plus 4 comes over here, becomes minus 4. So it's 3 minus 4, or there's a minus 3 answer here, isn't there? Minus 3 minus 4. They're my two solutions. 3 minus 4 is minus 1. Minus 3 minus 4 is minus 7. So minus 1 or minus 7, look at that. I've got the same solutions as I did up there, but I did it using the turning point form. So now I can sketch my parabola. I know my turning points, my x-intercepts are at minus 7 and minus 1, and my turning point's there. And my y-intercept is going to be this number here, 7. So I just have to run a parabola through here like this. And that's minus 7, that's minus 1. My turning point there is minus 4, minus 9. All looking good. My y-intercept is 7. And we've done the job. Okay, now in question 9, the difference is that they're surd values. Right? I'm not getting these nice integer values for my x-intercept, so I'm going to go and do 9a, and then hopefully you can have a go at the rest. So 9a, y equals x squared plus 4x plus 1. Alright, now I'm going to get this into, I couldn't factorize this if I wanted to. Look, multiplies to 1 adds to 4. It's not going to happen, is it? So I'm going to take the x squared plus 4x plus 1. I'm leaving space here for my, alright, what is it? Double that, halve it, and square it. Don't plus 4 on both, plus 4 minus 4 to neutralize that effect. Okay, so continue. X plus 2 all squared. Remember, this number is always half of that number. We've done loads of these now. 1 minus 4 is minus 3. This is y equals. What's my turning point? You tell me, shout it out loud. It's the opposite of that, isn't it? Minus 2, and then as that reads, minus 3. That's my turning point. I want to know what my x-intercepts are. So I make y equal to 0. 0 equals x plus 2 squared minus 3. Alright, now my method here is to take my minus 3 over this side, x plus 2 squared. I'm switching that to the left side as well. It's a busy move, that one. Now, take the square root of both sides, so it's pretty straightforward, but at this stage, I now bring in the square root of 3. Because that here is, up here in this state, at this stage here, it was square rooted to 3, and it was a nice thing. Here it's a third. It's coming into square root of 3. Now I just need to subtract 2. I take my 2 across, makes minus 2 over here, minus 2 plus or minus the square root of 3. So I've got 2x intercepts. It's minus 2 plus square root of 3, and minus 2 minus the square root of 3. Now they're both negative values, because square root of negative 3, sorry, square root of 3 is less than 2. So these are both negative values, so they're going to be over this side of, like this, roughly. My turning point is at minus 2 minus 3, so that's going to be pretty good. And my y-intercept, I imagine, is up here somewhere at 1. Alright, so that's 1. Doesn't look like 1, but it is. Turning point is minus 2 minus 3. That's that point there. And this is the lower of these two. It's minus 2 minus the square root of 3. And this x-intercept is minus 2 plus the square root of 3. And we're done with that. Okay, I'm going to leave that for you to continue with exercise 7D and knock over those work requirements. I'll see you soon.